Good morning, everyone. I'm Amy Till, Programme Director at NLA. Thank you for joining us for this technical seminar that we have for you this morning on residential ventilation. We've got a few more people trickling in. Hello to you if you've just arrived. So this seminar is part of our Don't Move, Improve program, and I'm sure as many of you know, this is our program that celebrates exemplar domestic design and the very best and most innovative home improvements across London. This year we're introducing a series of professional CPD seminars, of which this is one. It's the first actually, and we also have some professional evening talks and networking. This morning, I'm very pleased to hand over to Ian Palmer, Head of UK Specification at Airflow, who will be presenting for you this morning. And we'll save 10 minutes at the end for any questions that you have for Ian. So do pop those into the Q&A as we go through, and we will come to them at the end. Great. Over to you, Ian.
Brilliant. Thanks, Amy. Okay, I'm just going to share my screen now. Okay. I think you can all see that, hopefully. So yeah, as Amy said, my name is Ian Palmer. I'm the Head of UK Specification at Airflow Developments. And so today's CPD, it's REBA approved, and it's all about understanding residential mechanical ventilation and heat recovery. So just to start with, to give you a brief background on Airflow Developments Ltd. We've been in the industry of air movement and HVAC since 1955, so over 60 years now. Airflow, we actually started up by making airflow measurement devices in a small factory in High Wycombe. We are actually still based in High Wycombe to this day. We also have subsidiaries over in Airflow, Germany and in Czech Republic. Our product range has expanded from airflow measurement devices to domestic extract fans, residential fans. We also do a range of inline fans and industrial flue dilution fans, as well as our MVHR units, so our heat recovery ventilation units. So just to give you more of an overview of our product range, these could also be found on our website. So today we're going to cover off all of the different types of ventilation products available and their benefits. And yeah, the main focus is of course MVHR, mechanical ventilation with heat recovery. So just to go over what the course contains today. So we're going to start with why we need ventilation, the effects of poor ventilation, cover off a bit about the building regulations and compliance guides, including the approved document F. Then we'll go into some detail on ventilation with heat recovery, talking about the ducting and the install, and finish off with how the whole system is measured and gone through building control. So to start with, why do we need ventilation? Well, firstly, ventilation is required to provide fresh air into the space, into the building. Secondly, it's there to dilute and remove airborne pollutants which have been built up inside the building via the occupants or via the materials and furnishings, and cleaning products, things like also candles, anything that affects the air negatively. Ventilation is needed to dilute and remove pollutants. Ventilation is also needed to control excess humidity arising from water vapor in the indoor air, so mainly from your wet rooms such as your bathrooms and your kitchen areas. And you also need to provide ventilation for fuel burning appliances such as gas cookers. So how we used to build houses, it's obviously changed. The characteristics of a typical Victorian house, they tend to, well, we say they rarely suffer from indoor air pollutants, but most buildings do. But the reason the older type buildings may suffer less is because they're quite leaky buildings. So you've got quite a lot of air coming in and out naturally. And most rooms, they're typically achieving five air changes an hour. They've got open fireplaces with large chimneys. They have air bricks installed and drafty sash windows, maybe just single glazed windows, bare floorboards. All these sorts of things enable air to move in and out the building freely. But nowadays, of course, our buildings are becoming more and more airtight, more and more energy efficient. So with new builds now, we have open solid fuel fireplaces. Very rarely air bricks in new builds. Of course, fitted carpets. We've got central heating. They're thermal bridged. They're insulated. Everything that makes a building airtight is in these modern buildings really has a negative effect on ventilation. So it's even more crucial that these new builds are installed with the correct ventilation. And also, which is quite topical with Don't Move, Improve, is the fact, even if you're renovating an existing property, whenever if you're replacing the windows, for example, or the doors, and that they're going to be more airtight, then you need to make sure when you're making these changes that the ventilation is not negatively affected, and if so, then you may need to upgrade the ventilation in the property. So yeah, the result from making these buildings very airtight is that you're almost in a bubble. Yeah, the picture below, it's kind of like you're in a sealed plastic bag, really. So it's kind of the fact there's very little air coming in or out because the building's so well insulated. Yes, it'll be cozy and it'll be warm, but it will also be full of airborne pollutants if the ventilation hasn't been sorted. And yeah, in the wet room areas, in your bathrooms and your kitchens, this is where you'll have the moisture problems, and this is where you're going to have to really control that level of humidity. So there's an example here: a family of 4 produces up to 14 litres, 24 pints of moisture a day. This is just from bathing and showering, washing and drying, cooking, and just breathing. So it is important that, particularly in the wet room areas, that ventilation is installed and installed correctly. So the effects of poor ventilation, yeah, in a perfect environment, there's in a perfect environment for the I don't even know what that first line is, but with the effects of poor ventilation, it can trigger things like asthmas, allergies, and skin disorders. Usually, if you've got high humidity levels, typically over 70%, these sorts of things will start to cause things like mold, mildew, in the wet room. So controlling humidity levels is really important, and improving the air quality inside the building is also equally important. So we've got a number of drivers driving ventilation and driving improvements on buildings, and obviously the key driver is the building regulations. So on the domestic side, we have approved document F, L1A-B, and L2A and B. And the regulations are consistently changing. They're currently under consultation at the moment, with new regulations due to be released any time now in terms of improving the home and for new builds as well. So document F, it goes into detail on the different types of ventilation systems available and what you can install. So starting with system 1, we've got intermittent extract ventilation. System 2 is passive stack ventilation. System 3 is central mechanical extract ventilation. And system 4 is mechanical ventilation with heat recovery. So throughout the building regulations, these systems are often referred to, and it will tell you in what instance which system is the most appropriate and which systems maybe shouldn't or cannot be used. So to start with, system 1, which is intermittent extract fans. So these are extract fans that are located in a wet room, so bathroom, kitchen, utility, WC, and they replace the air that enters into the building via background ventilators in all rooms, usually in the form of window vents or trickle vents. So you see in the little diagram to the right, you've got the air coming in through the windows or for the trickle vents, and then the air is extracted out through the extract fans back out into the atmosphere. So system 1, intermittent extract fans, they can be turned on and off. Quite often they're connected up to a light switch. So when you turn the light on, the fan comes on, and when you turn the light off, the fan would go off. So in some instances, and it's important to remember, where you don't have a window in this room where you have an extract fan, then the fan must have an overrun timer. So when you turn the light off, the fan won't go off straight away. It will run on for a certain time before eventually turning off. So it is a requirement in the building regulations where you don't have a window that the fan should have an overrun timer. So ideal for new build and also refurbishments. So system 2 is passive stack ventilation. So this type of system is rarely used nowadays because it can't be controlled, to be honest with you. It's all done via the wind. So there's no, it's non-electrical, non-electromechanical, and it's a very, very old way of ventilating, and the building regulations are now pushing for this type of system to not be used anymore. So system 2 is slowly being written out of the regulations. There is some instances where, yes, it may be the only option, but ideally system 2 is not the best way to ventilate. System 3, this is your central mechanical extract. So this is a continuous extract system. Quite often you'll see a centralized extract box, like the diagram over there, where it's extracting from all of the wet rooms throughout the building. And rather than having individual fans per room, you've just got the extract air valves in each room, all being extracted back to that one centralized unit, which then extracts out into the atmosphere. So this is a continuous system, so it is always running throughout the day, 24/7, and it's always running at a very low trickle rate, so it's very quiet when it is on continuous operation, and it will have the capability to boost, for example, when you do take a shower, or when you're cooking downstairs, it will pick up the humidity levels, pollutant levels, and the extract unit will boost, increase its extract rate so that it's extracting more air from these areas when they are in use. And we call this system DMEV, Decentralised Mechanical Extract Ventilation. System 3.1. This is also very similar to the decentralized extract. However, these, again, you've got individual fans per wet room, and rather than like the intermittent fans where again you turn them on and off, these ones would be continuously running. So again, throughout the day, 24/7, they'd be on a continuous low rate, so again very quiet. They're constantly extracting air from the property whilst air is coming in through the windows or through the trickle vents. The extract fans are continuously working, but at a very low rate. And again, they would boost when these rooms are occupied, and when the showers are on, and when the cooking is taking place. And again, these would just be located in the wet rooms. System 4. So system 4 is mechanical ventilation with heat recovery. So this is a whole house ventilation system. So whereas you have with the extract fans, you just have extract fans in the bathrooms, in the kitchen areas. With heat recovery, again, you would extract from the wet room areas, so the bathrooms, kitchens, utilities, but you would supply to the habitable rooms. So you notice with the diagram on the right, there isn't actually any air coming in through the windows. So with this type of system, you don't require trickle vents in the windows, because the mechanical ventilation heat recovery system is doing all of the supply and all of the extract to the whole building. The diagram shows the heat recovery unit up in the loft space. Ideally, now the regulations are pushing to say this type of system should now be installed down in the heated envelope inside the property itself, so in the utility cupboard, or down maybe even in the basement area, because in the loft space, if it's not insulated, there's a lot of heat loss. So this type of system, it is supplying and extracting to the whole building, but also recovering your heat. And as we go through the presentation, I'll just detail a bit more on the MVHR and how it works. So what is ventilation with heat recovery? So you've got the heat recovery process works when you're bringing the air in from outside and extracting air from the room, so from the building itself. So say your room temperature is around 21 degrees. When it's extracting from the room, roughly 90% of that heat, so say 19, 20 degrees of that heat is being stored inside the heat recovery unit, so that when the fresh air is brought in from outside, it crosses over the heat exchanger and supplies the fresh warm air back into the building. So the benefits are that you are saving a lot of your heat rather than just letting it out through the window in the wintertime. But also on the supply side, you're supplying fresh air in, which is then filtered before it goes into the building. So nowadays we have really good filtration systems on our heat recovery units. We often use what we call an F7 pollen filter now, which improves the indoor air quality and gets rid of other particles and cells that again can trigger asthmas and allergies and all sorts of things. So with an MVHR system, you're not just recovering your heat, you are also improving the indoor air quality. And of course, the heat recovery system is always extracting as well. So it's extracting the stale polluted air and all the pollutants that have been built up inside the building itself, like your VOCs, CO2s. This diagram here just shows you how our common heat recovery system works. So this is a heat exchanger system. So as I mentioned, it extracts the air from the building, crosses over the heat exchanger. The hot air is stored inside this plate heat exchanger. And then when the fresh air is drawn in from outside, again, it crosses over, warms up that fresh air, and then supplies it into the building. And on either side of that heat recovery heat exchanger, you've got filtration. So you'll have a pre-filter for the air coming in, and then a post-filter to make sure the air going into the property is filtered to that higher standard. So going on to the installation of MVHR. So why bother installing MVHR? Well, we've got ever increasing energy costs, government regulations to reduce carbon emissions and conserve heat and power. So this equals higher levels of insulation and air tightness in both your residential dwellings and commercial buildings. And the answer is to continually supply fresh filtered warm air into the space. Of course, the best solution to do that is via mechanical ventilation with heat recovery. This is a typical unit. You wouldn't actually see this. This is the actual inside of the unit itself. So it's just to give you some idea of the components, but actually the front of it will just be a white cover. So it disguises quite nicely into a utility room. We do also do models that you can sit above a kitchen hob and be integrated into the kitchen units themselves. So the components here, you've got your plate heat exchanger in the middle there, which is doing all the work in terms of recovering your heat. You've got your two supply fans, one extract, one supply. These are EC fans, so electronically commutated fans. They work continuously throughout the day, and it's all run automatically, the unit, via the built-in intelligent controls. We've got the supply and extract filters there. And again, the additional F7 pollen filter, which is to filter air going into the building to that higher grade. Importantly, the units also have an automatic summer bypass. So in the summertime, you don't obviously want to be recovering your heat. You want to be slightly cooling it down. So in the summertime, the unit will automatically bypass the heat recovery and supply fresh air, fresh filtered air into the building. So there will be a form of free cooling by a couple of degrees when this automatic system kicks in, and it's all done based on temperature. So it picks up the temperature levels, and when it reaches a certain temperature, the unit will automatically bypass the heat recovery. There is an option for a built-in preheater and post-heater on these units. So with the heat recovery, because it is so high now in terms of efficiencies in the region of 90%, quite often people still like to maybe top it up a few more degrees to make it comfortable. But you will, of course, have a primary heating source in place anyway in the building, whether that be central heating, underfloor heating. Details on the heater, details on the construction of the unit there, galvanized steel, this model in particular. And a condensate drain is fitted to the unit as standard, because when you've got the hot and cold air crossing over, there is a slight bit of condensate that does form. So there needs to be a condensate drain in place to enable that small amount of condensation to be drained out of the unit. So the these MVHR units come with controls and functions, so there's various controls and functions you can do. Nowadays, the units are connected to the internet, so you can actually control and monitor them from your phone, from your tablet, from your laptop. But they do also come with their own controllers as well, so you can have that manual control if required. Although the MVHR system, it is an automatic system, so the idea is, and what's quite pleasing for a lot of homeowners, is that they install it and then the unit will just run automatically throughout the day, throughout the year. These units also have built-in CO2 sensors, so they can run entirely based on the CO2 levels. So if throughout the day the building's unoccupied, the unit will ramp down, the speed of the fans will slow right down, and it will just trickle throughout the day until you get home. When you get home, it will pick up the CO2 levels and it will increase the ventilation. Again, even if you were hosting, you had people around, again, the CO2 levels will rise. So again, the CO2 sensor will talk back to the unit controls and it will tell the unit fans to ramp up accordingly and provide more fresh air in and extract more of the air out. So there's a number of different options available there in terms of your controls. So just talking briefly about other influences that drive MVHR systems and ventilation. So we have passive house. So if you're designing a building to passive house standard, you will need an MVHR system in place because that passive house is going to be so airtight. There really is a must for MVHR, because you'll need a mechanical ventilation system to supply and extract air into the space. And then that MVHR system alone has to also be passive house approved if you want to achieve that passive house certification. So talking about the install of these systems, this is one of the downsides at the moment in the industry. We do come across it ourselves where some of these systems have not been installed correctly according to the building regulations. And you'll see a few examples on these pictures, these with ducting like this. Ducting is the main cause for poor installs. So if you don't get the ducting right, it will affect your MVHR system negatively. So with the ducting, if you've got lots of bends in the ducting, if, for example, you're using a lot of this flexi ducting, which crushes, it all adds a lot of pressure, a lot of system pressure, and it means the fans inside the MVHR units are having to work a lot harder against this pressure to push that air or extract that air through the ducting and out or into the building. So it is important to get the ducting correct and have a professional install this for you. So with the ducting, we recommend that you use rigid ducting or semi-rigid ducting so that it reduces the pressures and enables the air to run smoothly throughout in or out of the building. And also with the rigid or semi-rigid ducting, rather than where you've got this flexible ducting which can break, it can bend, and it can cause leaks. All of this adds to the pressure. So with the rigid and semi-rigid ducting, you avoid that entirely. So this is the example of this semi-rigid ducting. So it can be bent and shaped around beams, and it doesn't actually crush. It's very versatile, very strong, and it's also smooth inside, has anti-static, so there's no build-up of dust and dirt, and it just does fit very nicely into the building, and it can be hidden away. So this is one of the most recommended types of ducting to use on an MVHR system. It's very quick and easy to install. You just clip the ducting together, put them into distribution boxes, and the benefits are that it's very quick and easy to install, and there's zero leakage, which lowers the overall pressure and means that your MVHR system doesn't have to work against such high pressures, which means overall that it'll have a longer lifespan, the fans will run for a lot longer, and it's going to be a better overall system for you. So the solution here, the installation and the performance. So you could typically with the semi-rigid ducting, they're roughly around 75 millimeters in diameter, and you've got the options to have flat or oval. And it's a radial design directly to each room. So it goes to each room, habitable room, and your wet room areas. Saves time on installs, easy to fit in joists, and you can pull it through narrow gaps down cavity walls quickly and easily. So in terms of the performance, it minimizes the inter-room noise transmissions. It's got high crush resistance, so it can actually even be buried in concrete, and low resistance pipe compared to the flexible ducting solutions. The advantages are the hygiene side of things, where I mentioned about the anti-static. There's less dust and dirt buildup, so less cleaning of the system has to take place. And it's just it's also a cleaner, tidier install. You don't have to use tape to connect the ducting to, which you might see on the flexible system. So where I mentioned about getting a competent installer, so Airflow, we recommend teaming up with NIC EIC. They have a list of recommended installers. Airflow also hold this NIC EIC training course at our head office, where installers can take part in this training course on how to correctly install and then test and measure the ventilation. The picture on the left there is one of our colleagues just using an airflow measurement device to test the fan to make sure it is performing. Excuse me. So in summary, mechanical ventilation with heat recovery, MVHR, installations help to meet the challenges of saving energy and providing best practice. Fitted by a competent person to the correct specification, they deliver effective quality ventilation in both new build and refurbishments. Thanks very much, and I'll take any questions.
Thank you, Ian, for your very detailed and insightful presentation. Do pop your questions into the Q&A if anyone has anything they would like to ask Ian. I will put that to him. We've had one coming straight in. Ian, maintenance of MVHR units, how often do filters need replacing?
Yeah, thanks, Amy. That's it's a common question, actually, and yeah, very valid. It's all depending on where your building is, because if you are in a highly polluted area, if you are in a city centre or town centre, the filters will need replacing a lot more regularly, maybe 2 or 3 times a year. Whereas if you're in the countryside, it could just be maybe once a year, if that.
Thank you. Thanks, Maria, for your question. Another one here from Adam. What's the approximate cost of installing a new get my acronyms right, MHVR system into a 3-bed new build property?
Well, Airflow ourselves, we don't carry out the installs, so it all depends on the contractor you use. And yeah, I mean, I could give ballpark figures, but it's not really going to help you. The best way to do this is to speak with with either ourselves and provide us with the plans of your building, so that we can measure it up. Because firstly, what we need to do is we have to work out the right amount of ventilation required in the whole building, then that will be able to determine what size unit you need. And then it would also be able to determine what size ducting you need and how much of the ducting you need throughout the property. So all of these are going to have an effect on the overall cost. And yeah, I can't really give a cost until we have the right information.
Thanks, Ian. So in a refurbishment scenario, can you install this system just into the extension, or does it need to be installed throughout the building?
It depends which type of system they're talking about. If they're talking about MVHR, then yeah, MVHR.
It's MVHR, yes.
Yeah, okay. So if they're talking about MVHR, if you're installing it, even if you've just added an extension, the MVHR is a whole house system. So it's designed, and the reason for it is to supply an extract to the whole house. So yeah, it wouldn't just be for the extension, it would be for the whole house.
Thank you. Question here around acoustics and noise of the MVHR units. What degree of noise, and have you got any recommendations on where to install acoustic rating of the partitions?
Yeah, in terms of the acoustics, so with the units throughout the day, a lot of the time they'll just be running at a trickle speed. So the fans will be running at quite a low speed, which will mean that it is in quite quiet operation. Often these would be installed in a utility area, so where your washing machine and everything would be. That's where we'd recommend them to go. Of course, we have seen them up in loft spaces and in basement areas as well. But yeah, we would say obviously not to install them close to a bedroom, because yeah, you might hear some of the humming at night, even if it is only on trickle speed. But when you're using the wet rooms is when the unit will boost, so that because the fans will then be running faster, it might be slightly noisier, but because these units are so well insulated, the noise is minimal.
Great, thank you. So that's it on the Q&A questions, but in case anyone's just having a think of another one, I have a quick question for you, which is just around heightened attention to our air quality in the context of viruses and bugs that might be in the air. And I wondered whether that's something that you're seeing an increase in questions and around, and any products that are tackling that specific kind of request.
Yeah, definitely. At the moment, of course, it is on the tip of everyone's tongue. It's about COVID and about ventilation and how it can positively reduce the effects of COVID and the effects of viruses in the air. So with any type of ventilation, whether it's just extract or whether it is a supply and extract MVHR system, it's all helping to get rid of pollutants, including virus cells, including bacteria. So MVHR is one of the best ways to do that, because it is supplying the fresh air, fresh filtered air in, but it's also extracting these pollutants out. And then using something like an ion generator or a UVC filter. These are newer types of technology now being used to help reduce virus cells and bacteria in properties.
Thank you. Another question here around installation of the main element of MVHR into a utility. What are the typical dimensions you would need to allow for?
So yeah, again, it kind of depends on the size of the property. The smaller the property, the smaller the MVHR system. And again, we would just have to look at the plans to give you a rough size, a rough dimension of the unit. But yeah, typically they could be, you know, the size of a small box, leading up to quite a large box, so it's quite a wide question, one difficult to answer, and until we have like plans of the building in front of us.
So Ian, we've put you on the spot with a couple of quite technical questions.
That's okay.
Watching, if they want to get in touch with you directly after this to pick up with you, what's the best way for them to do that?
Yeah, so you can contact us directly. So Airflow, we've got a direct email, which is just info@airflow.com. And if you do specifically have a project you want to talk about, usually we would just require the plans of the building, and we can help in terms of looking at the right amount of ventilation needed for that space, and then we can start talking and looking into what size unit they'll need, how much ducting they'll need, and we can then again go on to talking about recommended installers as well.
Great. Another question here. You mentioned ion generators and UV filters. Would that be something that is added to the unit, or is that a separate mechanism that needs to be installed?
Yes, so it would be something that you can either add to the unit or add into the overall system, into the ducting system.
Great. Well, it looks like we might be able to wrap a little early. Final call for questions from our audience.
I was just going to let everyone know, actually, Amy, there's a product that we haven't shown in this presentation that's actually a single room heat recovery system. So those types of systems that I've just shown in the presentation, that's it. Again, it is a full heat recovery system for the home. So it supplies and extracts the whole house. But we also do smaller single room heat recovery units that can be installed through the wall. So they're kind of ideal for retrofit. So again, if you're looking to make home improvements and you want to have heat recovery, but you don't want to have a unit with ducting going throughout the building, we can also offer a single room heat recovery solution where it supplies and extracts in the habitable rooms. And then you've still got an MVHR system, but it's just retrofitted through the wall.
Great. Any other final words for our audience, Ian?
I just want to say, yeah, thanks very much for listening. Appreciate everybody's time, and yeah, feel free to get in touch with Airflow if you have any more questions about ventilation.
Brilliant. Well, a huge thank you from us to you and Airflow, Ian, for putting on this seminar. Very timely. And to all of those tuned in, we'll be popping up a quick feedback questionnaire after this. We always love to hear thoughts on what is most useful to you for these seminars topic-wise, so that we can try and put on a program that meets the needs of things that you're working on right now. Final Don't Move Improve plug is just to remind you that if you are looking to submit one of your projects to this year's competition, the deadline is the 17th of November. So Ian, thanks again. I think we'll wrap there, and have a nice day, everyone.